Hi, I'm Alex, and this is my demo video for the software that I've created over the last 4 weeks, ScanForge. It's a platform which can create 3D models using photos and videos. I'll get onto that later. Um, I thought of this idea because of initially it was my passion for robotics, as I've been doing First Tech Challenge for the last year, and I wanted to do something that can take a camera input and then do something with that camera input. That led me to finding the idea of 3D rendering, which I thought was fascinating. So I then took that forwards into my project, and now I've created ScanForge, which I'm really proud of, and I'll be presenting to you now. I hope you enjoy. Hello, and welcome to my demo of my software, ScanForge, that I've created for the BetterMind Labs AI and machine learning program. It is a software which can take a photo or video input and create a 3D rendering of it. Here on the left of the UI, we see the Inputs tab, where we can select, say, this car as a demo image. Then the next step is to select our model, ranging from small to large, where small is the fastest but least accurate, while large is the slowest and the most accurate. This is due to different amounts of data taken from the common object in context dataset, on which each model is trained upon. For this car, small is good enough as it is the fastest. Then you choose the segmentation method. So auto is the most efficient way, whilst clean background can be used if otherwise the photo rendering isn't coming out properly. Then you select the depth spread, which determines how deep the box goes in relation to its width, therefore how stretched the object is. Around 0.7 is a typically good spread. Then you select the number of points which the AI plots onto the car, determining how smooth the final object looks, by which a large amount of points is most effective. Once you've selected all of these and put in your image or video, you can just click Forge 3D. It'll pop you out to another tab, which is the tab viewer of the model once it finishes thinking. Here, if we go to this other tab, I've already created a viewing model of the car. We can see that it is plotted onto a 3D plane here, and as we go around, we can see what it has done. From the angle at which the photo was taken, it looks very accurate, as you can see here. The car looks just as it does in the photo. While if we go up, for example, we can see that there are actually large holes in it. This is because the AI can't, in and of itself, create what it doesn't know exists. So that's a limitation of our current software, which I will potentially work on later and improve. The last bit of UI for inputs is seen up here in the top right, the point size. So if we zoom in, we can see how each individual pixel is laid up and how it changes size as we move the slider. So right now we can see each individual pixel is quite small, whereas if we move the slider all the way to the right, it's quite large, creating a smoother object. This can be used to change how you view each object. So right now it looks a little bit blurry, but it also looks much smoother than it does when there are very small points. Once it has finished forging your model, it'll take a little bit of time, especially on the first run, as it needs to download the weights of the model and see the data. We'll come back to this, but for now, while it's thinking, we can check out the back end of the whole system, which runs on VS Code. Here we can see in the terminal how it saves images and then it goes through each process, telling you one at a time what it's doing. So it goes to check the uploads, puts in the output, puts in the PNG output, and it's continually thinking. And right now it's processing this image that we've made here. If we check up here in the top left, we can see the spatial 3D folder, which is what contains all our code. Main.py runs the whole program, whilst ABC, app.py, and engine.py contain the code and the architecture, which runs as such. It takes the image, it segments it using a mask RCNN, which then takes just the image, removing the background. Then it checks the depth it estimates how deep each point should be, and then it creates an oriented bounding box, an OBB, around the object, from which it then plots each point at the detected depth into a graph. Here, if you just saw the terminal updated as it had finally finished processing the image. So if we go back to the front-end software over here, we can see that created is the viewer of the car, an image with the OBB around the car to show what the AI is detecting, and the graph-based image showing what the AI has detected. In the outputs, we can also see what it is, how long it took, the size of the box, and we can download each of the output mechanisms. Thank you for listening to my demo.